Just giving some time for everyone to fill the room. And this is the proactive, this is a long title, proactive open source software security, a webinar around this topic and how data analysis and hackers make open source safer. And I'm going to be moderating, and I have a few of our guests and also, right. And while we are filling up the room, just to share, Debricked and Detectify are both Swedish security companies. So we're saying hi to you from Sweden. And if you're learning about either one of our companies for the first time, I can just quickly share a bit about Detectify, since that is that's where I'm working at. Detectify is, we want to say we're better than your average app scanner. So we collaborate with the best ethical hackers to relay research from hacker to scanner in as fast as 25 minutes. And we are focusing on the web application security. And what we do is we verify the payload, verify vulnerabilities with payload-based testing, and which we will actually go into and show you a bit on how we collaborate with hackers, and also what that looks like when we build some modules. I believe that's what Spencer will go into. And then, yeah, we basically only alert when things are exploitable and things that we can verify. And so you can bring safer web apps to market with Detectify. And we like to say, go hack yourself. And so for those who are interested, we will be having some product demos at the end of this, since that was requested by people doing the registration. And that will happen after the presentations and Q&A. So I'll quickly just introduce we have two speakers today, as you can see on the screen. We have Emil I forgot to ask you, Emil, how to say your last name, but Emil Wåréus is a co-founder and head of data science at Debricked. And Emil has been with the company ever since they were just a couple of guys in a small room trying to solve security problems. And now he's the brain behind the algorithms that lay the foundation for Debricked's product, all while conducting research at Lund University and taking on fun projects such as cloning all data in GitHub, all at the same time. So in his spare time, Emma likes to code alongside a nice glass of wine and playing with his cat. And that's great, and we'll hear more from Emil later. And we also have Spencer joining us from Detectify. He's a security researcher at over at the Detectify crowdsource side. And his past experience includes security analyst work with NBC Universal, iOS engineering for an AR startup based in LA. And he likes Bitcoin, probably too much, probably a little too much. So these are our speakers today, and feel free to ask questions along the way. We have a little contest going to encourage you guys to interact with us. That each company will choose the best question today, and for a price of either like a gift card, or you can choose to donate the amount to a project or a charity. So please ask away in the chat or using the Q&A function. So let's get started. We are 5 minutes past, so I'm going to hand it over to Spencer. He's going to start off the presentation today and kick it off with giving you all a look inside the mind of a hacker.
Thank you. Hello, my name is Spencer. Today I'll be going over a hacker's approach to finding bugs in open source security, more like my approach to finding bugs, at least, and Detectify's approach to open source security as well. So before I dive into the presentation, just a quick background on Detectify. As Josie said, we are a website app scanner, but unlike the other competitors, we use crowdsourced hackers from across the world to submit vulnerabilities from 0 days, critical CVEs, published research or private research as well. And we don't do version detection. We ask that they send a POC and payload-based modules. So our modules are request response focused. So we send a simple HTTP request and we look for various things in the response to verify the vulnerability exists. And unlike the other platforms like HackerOne and BugCrowd, we give a per hit payout. So the more popular a module is, the more hits and the more payouts a hacker gets in the long run. So a quick agenda for today's presentation. I'll go into my approach to finding open source bugs, generally cover how we approach it here at Detectify, and then kind of go over how we implement like open source security modules without giving away too much company information. So first, here's my approach for bug hunting. I think as an individual, static code analysis is very overwhelming, but with the right methodology, I think the process can be a lot more efficient. So below is kind of my 3-step approach to conducting open source research. So first, ironically, I go through dynamic analysis, but that's just because I'm more of a visual learner and a visual person, and I like to see how the application or the end product works. And I don't like to dive too deep into code initially. After that, I go into more reconnaissance, but using more OSINT gathering. So I'll go through GitHub and GitLab commits. I'll use Google queries with public boards such as Jira and Trello to find any exposed data on those exposed boards, as well as using Google BigQuery to not really do more hacking, but create word lists or do more analysis on sensitive files on a large scale. And then finally, I actually dive deep into static analysis and I attack it with low-hanging fruits initially. I use some tools that I'll get into later. And then finally, I use those tools to conduct taint flow analysis within the code. So first, recon into dynamic analysis. So for me, I think code is very overwhelming. I think there's no need to dive deep into the forest because eventually you'll be in thousands of lines of code. So I like to warm up before I do that and just see how the application works and truly understands it. So I always throw up a burp, log everything, and just observe keywords, variables, URL parameters, and just try to cross-reference that with the code once I dive into it. So this process or this phase for me doesn't take too long, but just gives me a healthy feel for the code and the product. Here's more where the juicy stuff I think happens. So first, I like to go and to Git repositories. For me, it's the Wayback Machine for open source code. For those who don't know, the Wayback Machine is a digital archive websites at any given point in time. So with Git repositories, it's very useful to go back and see all the different commits on all the different branches and see what developers have pushed to the repo. Some useful tools that I've found useful are TruffleHog, which searches for secrets within all commits and all branches of a repo, as well as GitRob, which searches for sensitive files in those repositories. So using these and just general analysis of all of the Git history, you can find some juicy information like old endpoints, and though those endpoints may not be active anymore, it may give you a hint as to other potential naming for new endpoints to look for in the application. You can also see some very suggestive commit titles, such as removed insert password or some password here. So you know that commit might have some good information for you to look through. And also I think fixed issues are very good because usually if there's one bug in one part of the application, there could be a bug in another part. So if you see a commit for fixed RCE or fixed SSS, I would look for those kinds of vulnerabilities in other parts of the code. After that, I like to look through public boards and forums. So using advanced Google search operators or Google dorking, I try to find any exposed Jira or Trello boards that can potentially disclose credentials, issues, bug tracking, or any other sensitive endpoints. Also, I found Stack Overflow to be tremendously useful because a lot of developers tend to ignore security and want the end result as fast as possible. So a lot of times they'll reveal sensitive code or credentials or even system architecture at times, and that can give you a better understanding of the target at hand and where to go from there. And then finally is Google BigQuery, which is a REST-based web service that allows you to run complex SQL-based queries on large sets of data. So Google just allows an individual like myself or any bug bounty hunter to run very advanced queries on large data sets at a given time. So in this slide are some examples of what you can do to kind of analyze some GitHub data sets. So in the first image is provided by Tom Nom Nom, who actually works for Detectify now. And in this image, we are doing, or he's doing, a search for the 100 most common log files from GitHub. And then from there, you can build a word list and then search for those log files on new targets. Secondly, is a query that retrieves the repo and the path to nginx.conf files, which is something that we used recently for our nginx misconfiguration research, which is something I'll also dive into later in the presentation. So now I finally dive into static analysis. So first I'll use some linting or just some tools to kind of find bad smelling code. So typecasting without any errors, very generic, superficial face value vulnerabilities at first to see if there's any warnings. And then I like to use grep in combination with any irregular expression patterns to find sensitive keys, dangerous functions, things like that. However, I found that grep and regex can be very false positive prone. So for me, I think semgrep is a very good tool to use. It's a fast open source tool finding bugs. It comes with pre-written rules to find common vulnerabilities, disclose secret keys, and security misconfigurations. And it uses regex-like patterns. However, they use these patterns specific to each language, which makes it more intuitive and less false positive prone. Next, CodeQL is another tool that I've recently discovered that I'm still working into my methodology. And it's able to query code as though it were data. So it converts a code into basically a SQL-based database. So here are some advantages of semgrep. It comes with pre-written rules. Most common, for example, most common client-side JavaScript vulnerabilities are included in these written rules. It also detects very common JSON Web Token security misconfigurations and can detect secret keys in code. It also can scan for configuration files in common, it scans for misconfigurations in common configuration files, such as Docker Compose, Docker File, and Kubernetes. And I think one of the coolest things of semgrep is that you can also port other security tools into your code base or into your methodology. So you can port Bandit or GoSec into your semgrep rules and not only have your pre-written rules, your custom rules, but also use another tool as well. So it's like an umbrella of a giant code base of static analysis tools. And now I'll briefly show a demo of how to use semgrep. I think everyone can see my screen, so I'm going to keep going unless someone says otherwise. But so here is very basic and poorly written code that semgrep would detect. So here it uses the JSON Web Token library in Python to decode a JSON Web Token. However, in both these functions, it does it very insecurely. The first one uses verify equals false, which means it does not need to verify any cryptographic hash with the JSON Web Token, which means you could tamper with any JSON Web Token and impersonate the user. The next function, I'm using non-algorithm. It doesn't use any cryptographic algorithm whatsoever, which means you can forge your own tokens and also impersonate the user. So here's a good example of a way to use semgrep. So what's really cool with semgrep is you can use the YAML files to create tons of rules and patterns to detect vulnerable code. So here, for example, we have rules. We have JWT verify false, JWT non-algorithm. And you can you can set the language to Python, and then you create the pattern. So here it checks for any line of code inside a function that has verify equals false in this decode method. Similarly, the same thing can happen with algorithms equals none in any function as well. And important to note is that semgrep does not work on Windows, but if you have Windows subsystem for Linux, then it should also work. So here you can do semgrep-f jwt rules.yaml and then have app.py as your target, and it should output the findings. So here it discovered 2 vulnerable lines of code in our app.py file. It's also very interesting, and what I really love is that you can output it as a JSON, which makes it very easy to parse and analyze if you have tons of YAML files and tons of rules that you want to look at after doing initial static analysis. Another cool thing with semgrep is that it can detect aliases. So in Python and in other languages, you can import a package as a different name. So here we're using Boto3, which allows you to log into Amazon S3 services. However, the alias is B3, but it'll just detect it as Boto3 and it'll convert it to B3. So it's very easy to use. So again, we can do semgrep, Amazon rules, app.py, and it should still detect that it's using an insecure line of code of hard-coded keys in the S3 login. So that's semgrep, and something that I find very useful, and I would suggest to use in bug bounty or open source efforts. So now going into CodeQL, again, this is not something that I've played around with a lot, but from my reading, I think it can be super useful. It converts source code into database-like structure, and then you can then make SQL-like queries on that CodeQL database. And like semgrep, it can support many languages, and each of those languages has its own standard library that you can make queries on. And also it's object-oriented, so each query can do encapsulation and also inherit from other queries. So for example, we see that we're importing the Python library. So our code is Python, and here we're just checking at any point is some bad function, so some name of function being called anywhere in the code. So this is very helpful for data flow analysis to see where sensitive functions may be called and what data is being passed through them. Similarly, we're just checking in this line of code or querying to see if there's any comments in the Python code that have to do. And usually these to do comments are very useful as they indicate potential vulnerabilities in the code that have not yet been fixed. And now we can get into the sources and sinks of the code. So using the previous tools, you can then find sources and sinks and do taint float analysis and understand how data is being passed throughout the code. So sources are JavaScript properties that are user controlled and potentially attacker controlled. So for this presentation, I'll talk about DOM XSS. So DOM XSS arises when a website passes data from a source to a sink, which handles that data very unsafely. Now, sources are anywhere that a user can input data, but it's most likely going to be in the URL a lot of the times. So common sources in JavaScript are the location object or the document object, as you can see here. Sinks are JavaScript functions that could potentially execute user-supplied input from the source. So eval and document body inner HTML could feasibly interpret and execute user-supplied malicious HTML and JavaScript. So using the previous tools, such as semgrep, you can find sources and sinks and see how data is being passed around. And then you can either go source to sink and start with all the sources in a code and see how the data is being passed to the sink. However, you can go down a rabbit hole, but you'll understand a lot of the application and code base that way and might find juicier bugs. Or you could start from the sink and work your way back to the source. And though you might find more bugs, they may not be as great, and you also won't understand the application completely. So it's really just up to you and your preference. But I prefer just to understand an application, so I'll take the time and go from source to sink usually. So now I can go into Detectify's approach to open source security. So here I kind of believe that asking you shall receive. So of course, hackers can submit any vulnerabilities that they deem that they want fit or that they want to submit. However, at times there's a specific vulnerability that's very hot right now and that we want submitted to our platform. So for example, a couple months ago, the Microsoft Exchange SSRF was being exploited by a Chinese state-sponsored group targeting many multinational companies in the US. So we asked the crowdsourced community for this actively exploited vulnerability. And a user in our network was able to find Microsoft's implementation of detecting this vulnerability in an Nmap script. And here we see that you submit a path to this endpoint with this header, and then check a response for a status 500 and negotiate security context as a string. We were able to build that into our scanner and now detect that SSRF over just 1 weekend's worth of work. Additionally, we can also search for sensitive keys or API keys. So a user or a hacker can submit an endpoint to a sensitive file path, such as aws.json, and then submit certain regexes to check for. And then from there, we'll send requests to those file paths that will contain sensitive information. We'll perform those regex checks, but also, like I said earlier, regex can be very false positive prone. So we're able to use an internal data set to ensure that we minimize the amount of false positives that our regular expressions could produce. And finally, we've done some Nginx research. I'm giving a talk next month more about this, where I'll dive deeper into it. But from a bird's eye view, we basically used Google BigQuery to download a data set of over 50,000 files. And then from those files, we were able to narrow down the most common misconfigurations. 2 of those misconfigurations were missing root location, which is the root directory. The root directive specifies where to look for files. So here you see the root directive is etc nginx. So any files under that folder can be read, which is highly dangerous. Second is off by / vulnerability. So here is a missing / after the alias value. So this makes it possible to traverse up one directory and then read the source code. So we were able to use BigQuery to find these most common misconfigurations. So that ends my part of the presentation. If anyone has any questions, we can take a quick question break now before Emil continues his part of the presentation.
Thank you. Let me just see here. Looks like we don't have any at the moment, but just want to remind everyone you can submit it using the Q&A, or feel free to, oh, someone has raised their hand. Oh, if you want to ask your question live, I can bring you on to chat. Soma, feel free to unmute yourself and ask your question, or if you can.
Hey, Mike, do you use any other automation tools for this process?
I personally don't. Just maybe some bash scripts to like automate just like grepping and going through all the different data once I get it to parse it. But I like to go with a more manual approach.
Yeah, that's it. Thanks, Mike.
All right. And someone asked here, like, do you have any, I think that's the same question, other automation tools? How about, I got a question here as well from the pre-registration. So do you have any quick sources like Spencer, like or just quick tips on anyone trying to get into contributing to the scene, like the security community as an ethical hacker?
I think the best way is first make a Twitter account, because that's where a lot of the hackers live, and post the research and see what they're working on. You can also contribute to also these open source tools. So SemGrep and CodeQL are both open source. You can contribute to those. They also have competitions of improving those tools as well. So just finding any way to contribute like that would help.
Oops, I forgot that. Yeah, awesome. Thanks so much. And if any other questions, feel free to type them in, or we'll have a Q&A at the end as well. So in case something else comes up. Otherwise, we're going to hand it over to you, Emil.
Great. So let me start off by sharing my screen. Perfect. Can you see my slides?
Yep.
Fantastic. So I'm from Debricked, and I'm gonna talk a bit more about the holistic view of open source vulnerabilities and try to dive down deep into vulnerabilities in the open source that you're using and how to determine if you're vulnerable and taking action on that. But first off, Debricked is a startup based in the southern parts of Sweden. It's based in Malmö, and we were founded in 2018, so it's quite young still. And we're about 25 employees currently, and have taken in some venture capital. But we're still very early in our startup journey and are not done yet, far from. And this guy right there with the worst hair day on photo day is me. And at Debricked, we do three things, or the overall thing we're doing is open source management. So we try to manage and find out what open source you as a company are using. And we look at that in three perspectives: open source vulnerabilities, licensing and copyright, and health as well, where health is our quality metrics on the open source you're using in a portfolio management perspective. Now this ties together neatly in a policy engine where you can set rules for how you should manage and what is allowed, for instance, licenses, or if you should be notified of particular security vulnerabilities in your continuous integration system. But with that out of the way, let's go into the presentation. And that's what we're going to talk about today. So I have three things on my agenda. I want to give you some insight into the trends of open source vulnerabilities, what's hot right now, and educate you on how to evaluate the performance of open source vulnerability scanners. And then we'll go into see if how we can determine if you're truly affected by a particular vulnerability or not. So to start off, most vulnerabilities comes from the National Vulnerability Database. And for you that are somewhat senior in this environment, this is no news to you. This yearly they disclose about 20,000 vulnerabilities almost. And there's been quite an explosion in the last couple of years in the amount of yearly disclosed vulnerabilities. But we at Debricked, we like to work with specific advisories as well. And I've listed two of my favorite ones here, Friends of PHP and C# announcements. And what we find in these specific advisories is that the quality of those vulnerabilities are a lot higher. They are way more contextualized to the software that is vulnerable, and usually contains more and better information on attack vectors and so on of that particular vulnerability. And we can also see in the graph the GitHub advisory, which is a quite new vulnerability source, but it's still growing and not at all disclosing at the same rate as NVD. But do note that all vulnerability sources here can contain each other's vulnerabilities, and it's very common actually. So be aware of duplicates. And from this larger disclosure of vulnerabilities, we can see that there's been quite a shift in what type of vulnerabilities and what weaknesses are being disclosed. In this graph, you can see how many vulnerabilities of each weakness type is being disclosed yearly. And we can see the pink reddish ones that's trending upwards at the top, which is cross-site scripting. It's becoming a lot more disclosed recently due to the rising popularity of JavaScript, which is a common vulnerability in JavaScript applications. And we can also see that there's a bit of a downwards trend as well in the almighty out-of-bounds operations or buffer overflow, where, for instance, the very famous vulnerability Heartbleed was actually of the bounds of memory buffer type. So how does this affect me, one can ask? We usually use a vulnerability scanner such as ourselves, where you integrate and give us access to your code, so we can scan your code and find out what open source you're using, and we map that to those existing vulnerabilities. But it is not completely new, but it's still a very maturing space. And we actually like to reason around the quality of the vulnerabilities in 4 layers, or the 4 levels of true positives. And this is actually adopted by Linux Foundation with our contribution. And we want to understand the quality of those open source scanners and the capabilities of them and what they're actually solving. So the 4 layers are at the very top. Are you using a vulnerable package and the vulnerable version of that package? There's usually some false positives in tools where you get notification that you're vulnerable, but you realize that, okay, it's mismatched on the version, or it's matched on a completely different package that not the package that you're actually using. And this is an industry problem today, but I'll go a bit deeper into this. And then at level 2, we have, are you using the vulnerable code of that vulnerable package? At layer 3, we have, is the vulnerable called during runtime? And in the fourth and final layer, is the code exploitable in a critical environment? Let's start off by looking at layer 1. So there are some challenges here currently in the industry where there are, for instance, first off, different standards for how vulnerabilities are disclosed and how you map that to a software, and for how you install software through dependency managers such as PIP and NPM. Vulnerabilities are disclosed together with a CPE, a common platform enumeration. And this is a unique identifier for a particular software and a particular version. And that sounds great, but this is not, CPEs are not what package managers are using. They're usually using something custom or a PURL, which is a different standard, where these two standards actually don't overlap. And it's a quite challenge to match CPEs with PURLs and find the correct software to a certain dependency or a certain vulnerability. And there's also the part where CVEs or vulnerabilities are disclosed manually, and it contains a lot of manual work to do that. And this means that sometimes there's little to no information or bad information attached to a vulnerability, which makes it very hard to contextualize to your software and correctly understand that, so that you're actually using that software that is vulnerable. And there is also the challenge with duplicate package names. I have this example here, which is I've been fighting a lot personally with. It's the click package. There's actually 2 of them in Python. So here we have a vulnerability, which is clearly a Python vulnerability. You can see that in the first sentence in the description there, where it says that click is vulnerable. But on the right-hand side, we have click, which is a palettes project. That's a CLI builder tool for Python. It's great. I've used it a lot myself. And then there is this other click package, which is not installable through pip and is less used, but still written in Python. So it's actually the left one that is affected by this vulnerability. But since the adoption of the other click package is a lot higher, and it's usually in the requirements files and so on for pip package management, it's really easy to actually match on those. And this is a quite common problem with duplicate names. So let's move on to the next layer, where we have, are you using the vulnerable code, or what code part of a vulnerability is actually vulnerable? So most vulnerabilities in those, the security risk is isolated to a small part of the code base. So I have an example here where we look at Netty, which is a Java component that has 2 main features. It has compression and decompression, and it has a web server. And there's actually a couple of vulnerabilities in the Netty package. We have a CV here, the decompression part. And we have 2 vulnerabilities as well in the web server part. So to understand this and match that with our software, to understand if we are actually vulnerable, even if we're using Netty and the vulnerable part of Netty, are we using the vulnerable part of the code? So we need to understand which functions, classes are actually vulnerable in the open source package. Are we using them, and how and where are we using them in our code base? So we actually do this automatically at Debricked, where we use our vulnerability database together with our clone of GitHub and all the code, where we first we match the different vulnerabilities with the different versions of the code. So we check out each vulnerable or non-vulnerable commit or release commit, and try to understand those different versions of the code by building a vulnerable abstract syntax tree and a safe abstract syntax tree. And then we understand what has changed in the abstract syntax tree to calculate what are the vulnerable symbols or the vulnerable functions and classes in this particular package between version 1.0.3 and 1.1.0. And this then becomes these vulnerable classes and functions. But of course, we need to contextualize that into the code that we have written as a developer using these open source projects. So from your code, we derive a call graph. And I know it's very hard or impossible to derive an accurate call graph. But in languages where it's easier, such as Go and Java, we are doing this statically. But in languages where it's basically impossible, such as JavaScript and Python, we intend to do this dynamically. And I will get a bit more into that functionality later. So from this, we do a matching of the open source vulnerable functions and classes to if you're using. And of course, it's not only direct calls, it's also nested calls where an open source project are using another open source project, which using a third one, and that's calling a vulnerable function. And this can be displayed in different ways, but this is just sketches for now. We're still in the backend part of this project. But we are thinking of just giving you a flag of whether you are using the vulnerable functionality or not. So here we can see the CV at the top where you're using it is actually the decompression vulnerability, and the other ones are the web server, which we're not using in this project. And to contextualize this into our software, we are showing the files that are calling and the rows of those files that are calling each vulnerable symbol. And here we can see that netd.decompression is called at line 25. And we can also see that authorization.authorize is calling another vulnerable symbol as well, but this authorization.authorize is not the vulnerable symbol itself, it's actually calling it under the hood, but we match that as well. But then we can also see here on the last row that in the test decompression, we are actually calling the vulnerable functionality during tests as well. But this is not as critical since it's only run in a test environment, and we probably don't need to care too much about that, right? And not prioritize that right now. Great. So looking at the third layer, we can ask ourselves if we're using this vulnerable code not statically, but dynamically during runtime. And we're actually conducting a research project currently together with Elasticys. It's another startup in the northern parts of Sweden, where we are sending the vulnerable classes and functions to the running environment and tracking and tracing those functions using a technology called eBPF. And this then can be displayed in a nice time series where you can view how much each vulnerable functionality is called. And then looking at the last part, the fourth one, and maybe the most critical one, is the vulnerable code exploitable in a critical environment? And this is a very, very hard challenge, but luckily we have another Swedish startup that's doing great things here. So thank you, Detectify, for solving this challenge for the industry. And lastly, what I want you to remember from this presentation is that monitor language specific advisories, they tend to be of a lot higher quality than the general ones. Especially, I really like the C# announcements because it gives so much more context to the vulnerabilities and how they and updates to when the repository has changed names and so on, which is great. There are different levels of true positives, and we should expect more overall from the industry. Currently at level 1, Good vendors have about 80 to 90% precision or true positive rate, and less developed vendors have about 60%. But we should expect that we get through all the layers in the future with vulnerability scanning tools. And to analyze the open source vulnerabilities, you must also understand what part is actually vulnerable and if and how you're using it. Thank you for me. If you have any questions, feel free to ask.
Thank you, Emil. Let me see here. All righty. Just remind, I think I sent it to the right chat, that we're eager to hear your questions, because we're going to reward some gift card or like a donation to your favorite project based on that. So we do have some. Always fun to start off with something about competitors, I guess. Emil, how do you compare with SNCC?
Yeah, that's our main competitor. So we are quite similar in our offering today to SNCC. But we see that they're moving a lot more into deep security, I'd call that, with container scanning and contextualization of vulnerabilities and so on. And they're doing a pretty good job there. But we are moving into what we call open source management and a broader space and a broader view on the open source you're using. We haven't talked anything about open source health, for instance, today, which we are working quite a lot with, where you can evaluate the quality of an open source project quantitatively. So, for instance, looking at the trend of contributors in a continuous manner, where you maybe want to understand if the open source project, what open source projects are actually the most important ones to you, even though you don't directly import them, and so on, and contextualize that to these open source health metrics, so you can really understand the ecosystem of the open source that you're using.
Great. I hope that answers the questions. Both were quite similar there. I have this one from the registration. So it was, I'm a data scientist with a specialization in predictive modeling who has found myself working increasingly in security-related investigations. So I'm interested in understanding how I can best leverage my skills for security purposes. Do you have any, Spencer or Emily, have any thoughts?
How one can best leverage their skills for security purposes.
Yeah, they are a data scientist with a specialization in predictive modeling.
Yeah. Like, that's exactly like what I'm doing. And I can just tell you a bit about other things at Debricked that we're looking at with our whole clone of all open source, basically. We are using a lot of machine learning to look at commits on code, on pull requests, on issues with NLP or NLP for code, where we are trying to predict and find undisclosed vulnerabilities, which is quite close to what Spencer presented. And we, of course, want to disclose them in a responsible manner. For instance, we have one algorithm where we look at issues, and we estimate that we find about 400,000 or 500,000 security-related issues on from different sources, and that's quite nice to compare to the less than 200,000 total disclosed vulnerabilities in open source. So I think there's a lot of opportunity in this space.
Definitely. I have one as well here. So as you said, we don't want to leave that hanging on our heads. This question is about how do we make sure while developing an enterprise level application that the data, where the data shared is confidential. So the question is, how do you look into security by, I think that was the thing. So how do you make sure basically, when you're developing an enterprise level application, that the data stays confidential. I don't know if that is a full question there.
I'd say that's a bit out of my scope, or it's a large question, and so I think there are good answers to that, but I'm not the right person to give it now.
All right. I don't know if you have any thoughts, Spencer. Otherwise, we can try this one. How can you secure your source code and sensitive info reside inside? I don't know if.
I think I understand that question.
Okay.
How to secure your source code. I mean, there are various tools that you can use commits, and even GitHub has a lot of now features that will detect if there is sensitive code written that will prevent you from pushing it or making commits to that. So that's one way, or doing your own analysis before pushing it out to open source. But also the benefit of having code as open source is, even if there is sensitive code, hopefully you have there's a good program where people will report vulnerabilities, then they're rewarded, further fueling our industry.
Great. I hope that answered the question. Okay, from Michael. So how about dependency confusion hijacking attack that was disclosed recently? How do you cover this aspect? I'm not sure if either one of you know which they're referring to.
It's actually a really interesting topic, and we haven't. It's in the future for us. I'd say we are in a very good spot to monitor this and help companies with this, since we have integrations to all package managers, all large package managers and GitHub, and we have encountered cases where we have discovered that people are actually using supply chain attack type of dependencies, yeah, we're in a good spot to do that, but I'd say that it's in the future for us. But of course, you can use whitelists and blacklists for that. This might be a feature for Debricked in the future.
Nice. And we have another question here from I'm going to butcher the name. Sorry, Imakeda. What is the best strategy when you start auditing your application for vulnerabilities? What are the pros and cons of using pen testers or a dedicated solution? Any recommendations for beginners? Anyone want to take this on?
I can try to tackle that. I don't know what that pen tester thing is, but a good thing when tackling huge code bases is kind of separating functionality. So authentication, if it's e-commerce, finding how payment works, or just separating functionality altogether, and then kind of setting targets for yourself. So say you'll analyze 10 files or 20 files per day, and then kind of having a working and written progress of that. And yeah, just kind of develop your own methodology. I think writing down everything really helps when it comes to this sort of thing. And in terms of getting started, you just have to get started, unfortunately. It's what everyone says, but it's the truth. And then through failure is success.
Awesome. Let's just give a few more minutes in case anyone has any more questions. I think that was it. There were some that are, I think this, let's see here. In the meantime, I'm going to launch one last poll, if that's okay. And we have two questions. Woo. Can you elaborate from Anders? 2 questions here. Can you elaborate a little bit on the false positive of Debricked? Can you guarantee almost 0 FP rate with your verification process? And secondly, do you cover transitive dependencies as well?
Yeah, so let's start with the second question first. Yes, we have full coverage of your transitive dependencies. So that's great. And one, it's very hard to reach a zero false positive rate. And the thing here is that one, can we calculate truly accurate abstract syntax trees, and two, can we derive truly accurate call graphs? And the answer is, of course, no. But I think in terms of false positive rate, I think you should look at it at a risk impact approach, where you can prioritize what you should spend time on. And this really, and with vulnerable functionality, you can see that, okay, these are vulnerabilities that I'm actually using statically, and I can see where. That means I should probably spend more time on those. And in the future, in the short future, where we look at runtime, those are, of course, a lot more accurate in terms of that we know that these functions has been called. Then there's only the part that we need to find the vulnerable functionality very accurately. And I mean, zero false positive rate, and that we find 100% of all potential vulnerabilities is unrealistic here, I'd say. But this really empowers you to work with the most impactful thing first, and in a short period of time discard things that you're not using.
Great. I hope that satisfied. Let's see here. Yes, thank you for the confirmation, Anders. One more here, Emil, for you. Automation or manual testing for finding vulnerabilities, which one is better according to you?
It's a hard question. I'd say, like, which one is better is really hard. I think that in all your security work, it's not about one or the other. It's about doing the most impactful thing for your security. If you spend all your time only doing security work on your application, you probably don't have enough resources to actually develop it for the future. So you have to do what is efficient. And I think automation is really efficient, and do that continuously in your CI and working with that as a part of your DevOps or DevSecOps, and doing manual testing or penetration testing once in a while, I think is really good. And we do that internally for ourselves, of course. That we usually find stuff, but in our experience, our own tool finds more and better things.
You have any thoughts, Spencer? Do you want to chime in?
Well, like I said, I like taking a manual approach. Automation, I mean, is also very good, but I think maybe a combination of the both, because I think nothing's better than just 2 pairs of eyes, just critical thinking at something.
Nice. And one more. But I think that's it for answers. So thanks so much, Spencer and Emma, for sharing your knowledge with us today, and about how we can use open source software safer and secure that. And we're going